one of our public lectures that we organized through the Malta Group of Professional Engineering Institutions that represents the IET, IMechE, and ICE, the basically UK professional engineering institutions. And through this group, we make public lectures and some other events, normally every Thursdays, every other Thursdays. Actually, we have 2 in a row, actually 3 in a row we had even last week. So please do follow the topics. Today we have actually our expert from CEA, which is the largest European research center in Europe and 3rd globally, right? We will explain later on. From France, Alexandre Mignonac, and he's actually part of Promise Project, which the Foundation for Innovation and Research Malta is also coordinating. So I will leave it up to you to introduce yourself, and I think the topic is of interest and it's debatable at the moment, so it's quite a hot topic. Thank you.
Okay. So hello everyone, thank you for your presence. I'm very happy to be in Malta and to be able to make this presentation. I hope this will give you some additional information on PV. So I'm a little bit expert on PV, but not at all in English. So I try to, but okay. So my name is Alexandre Mignonac. I'm here as part of the European project Promise, whose coordinator is Brian here, from here. And I'm part of the new technology of energy laboratory of CEA in France, and more particularly in the field of PV systems. So I will first present CEA solar department, then the current state of PV worldwide, and with some focus in Europe. So we will see it's very huge. And here I will make a focus on floating PV, floating PV at sea. We'll see different, and floating PV maybe in Mediterranean Sea. It's not easy place. Maybe question after the presentation. Okay. So first, some corporate presentation. CEA, it's a large French research organization which aims to bring key areas of research to France. It is made up 4 large entities. So we have defense, so this one is very close, protected, fundamental research, so low readiness level, low carbon energy and technical research, both treat about microelectronics with ST name, digital economic, and some part of renewable energy and environment. Here you see the solar department of CEA. So we cover a wide spectrum of activities from manufacturing of silicon lingo, so in white room, to cells, PV modules, huge chain, and at the end to network integration. It's very important things. You will understand maybe after. So we have storage activity also, and electronic power activity, management system, but main part is white room. So our first activity is to develop premium module technology with manufacturer for large PV systems. So here, quality, performance, and price are essential. One of our partners is Enel Green Power, Italian, which we support it in its PV module manufacturing plant in Sicilia, in Catania. It's old ST microelectronic site. So there are big goals for manufacturing, try to produce 5 gigawatts of module in Sicilia. So the goal is to participate in reindustrialization of Europe in the field of solar panel manufacturing. Right now, 80% of modules come from China, and the other is from Asia. So, and we need a lot, so it's a big deal to do this. And right now, there is a big dumping of China because we have a lot of modules in the harbor, so there is more modules and there is a war, I mean, economic war between United States and China, but will make modules at which price. So it's difficult for all, so we have to close a little bit, maybe, the political things. After today the drop in cost and the durability of PV have always been a very relevant technology for application, like historically for satellites. There is no piece, no component in movement, separation, and management very light. So the point here, it's not the cost. I mean, always the cost, but less the cost. But very light, robust modules are the key. And here, the function rendered by the module is essential. So we can see here we integrate on vehicles. So we are communication with Thales Alenia Space. We have some project in road. Here it's a road with Colas, French company. And on the left you have defense, because defense asks us to build module for remote system. And here it's lightweight module. I mean, we can use also this for like when the structure is too light to accept normal so add to this, as I said, we have system and grid topics, and it's this part to integrate PV production. We have to constitution of component models of PV, battery, and inverters. And from this model, we can work on the important area of optimal sizing, energy management system, and production forecasting, improve diagnostic and prognostic of performance. So all these tools make it possible to improve the function of PV system and integrate optimally production into the electric network. So I will speak about IEA a little bit because there is new reports of outlook of PV, etc. So one of sentence I put here, it's interesting. It's a conclusion of the report. I mean, here it's a PV plant I built with a partner in near my place in south of France. So some general context. First of all, we know that fossil fuels are main cause of global warming. Now it's new, it's known, and today they still represent the majority of our energy. So on the left, you have all we need on energy, including transport. On the right, only electricity production. In both, mainly come from fuel cells and coal, gas, and also petrol, oil for transport. So decarbonization requires reducing the use of this fossil fuel, and the renewable will contribute enormously to this effort. So I would like to make a focus on the International Energy Agency propose 3 scenarios depending on the state declaration and objective to limit temperature increase. So first, the state policy scenario steps provides an outlook based on the latest policy setting, including energy, climate, and related industries policy. This scenario will limit warming in 2100 to 2.5 degree. The other scenario, it's the Announced Pledges scenario, APS. Assume all national energy and climate targets made by government are met in full and on time. This scenario will limit the warming in 2100 to 1.7 degree. So it's not enough again. And it's not enough, and much additional progress is still required to meet the objective of net zero emission in 2050, and which limit global warming to 1.5 degrees. So here we can see there is here it's 2.5 degrees, but there is some uncertainty in possibility. There is a lot of publication on what the difference between 1.5 degree, etc. It's huge. So for in all scenarios proposed by IEA, you have here the three scenarios. All electricity consumption increase. See, we need more electricity. And why? Because we use it for transport. So step scenario, the most conservative one, estimate that the number of electric vehicles will be multiplied by 2.5 in 2030. So we need more electricity for that. And of course, there is also a part linking to the increase of population and standard living. We see that in all scenarios proposed by IEA, even the least ambitious, PV plays a major role. Here. So we know very well how to do main part of the objective, but ramping electrification, tripling renewable energy capacity. Here, maybe why is solar PV important? So solar PV is very modular. That can be manufactured in large plants with economic of scale, and you can deploy it in very small quantities. In PV, there is no scale effect. So you can address range of application from small to very large plants. It's very different from wind turbine, for instance. Today, utility solar scale PV is cheaper than the other option for new electricity generation. And rooftop solar is also growing faster due to rising details, electricity price. And also the technology is mature right now, and we don't necessarily have time to wait in 10, 20 years now. So some point where we are today, some figure about 2022 and 2030. So we have to go from there to there. And here it's conservative. Then the resolution is there. So in Europe, right now we are here, and each year in 2022 we are 35 gigawatt plus in Europe. The world is there. So we could achieve this objective, but it needs to be constant. Each year plus 26% of people. So here in Europe, it's 50 gigawatt per year. So this one is conservative one. Each year we have to put more and more. So we can do this, but there is some difficulty. I want to present this here. And PV production is identified at an important level of decarbonization, but the deployment of these technologies at different states are important. So renewable are said to contribute to 80% of new power capacity to 2030 in step scenario, with half alone accounting for with solar PV alone accounting for half of the objective. In Europe, we have to pass from 200 to 600 in 7-8 years. And the point is, solar energy is abundant on Earth, but its density is quite low. So therefore it requires a fairly large surface area. These huge surfaces must avoid impacting the environment as much as possible, like human use also, like agriculture. And to do this, it's particularly important to prioritize surfaces that already been artificialized, such as roof, parking lot, PV shade, for instance. And for land sites, already degraded sites are prioritized, like carrier or things like that. And other sites are subject to environment study. More recently, new PV installations have also been developed, used as support for agricultural production, and shading to avoid evaporation, weather protection, etc. There is a lot of demonstrator and tests in France or in Germany also, and also on body of water floating PV. You can see what's happening. Here is in Malta. So the strong development of photovoltaic power plant and the drop in production costs have led project developers to look of new space, like body water. So here we can see deployment forecast are interesting, even if it's only represent 1% of installed power in 2030. But mainly in Asia, you can see there. So today, freshwater system, like we can see, is mature, and huge power plants have already been built, mainly in Asia. Floating solar technology is now being developed over a large area with a multi-megawatt system. Where you see here we can see 300 megawatt peak floating system in China, I mean. So this technology is quite new, and there is lack of data sometimes on project, and better knowledge or more precise data would make it possible to optimize operation and profitability of this project. Here is an example of one project in France on Kerry Lake. My laboratory is working with this partner to optimize the site production and integrate feedback on this upcoming floating power plants. So we have a lot of sensor in there, and we can work on different points of the system. So how it look like? So a floating system is made up of visible parts like PV system on ground, but also underwater parts. And the underwater part is essential to the durability of the system. Its proper sizing to adapt site condition is it's key. So in particular condition, the climate condition like wind and wave, the type of soil, the operation condition on the basin with the tidal range, and the impact on the aquatic life. So one of point also, it's the cost of operation and maintenance. It's higher that in land. Floating. What about floating at sea? So the sea represents significant area. The coastal population is significant, and therefore consumption of energy. So today, manufacturers are studying the opportunity to deploy floating system with opportunities between offshore wind turbine in North Sea, for instance, because there is already facilities for connection, etc., grid connection. But the technical challenge are significant. We speak about corrosion and integrate the swell condition, tension on ensuring, and connection to the network. That's why for 2 years, the first demonstrator of different technology have been studied, and some have been deployed at sea. Initially, the project and demonstrator concerned protect sites near shore and estuaries, and to integrate first corrosion and little waves. And then some technology are being studied for site in open sea. So I will introduce you to some of this technology. So first, key points are similar as on freshwater site, but with additional of corrosion and stronger constraint on all points, particularly in wave, wind condition, but you have also grid connection, and all points it's difficult. Operation and maintenance, it's quite difficult also. So here, so some example, there is a lot of technology we see and demonstrator. So this one, they test this floating system for 3 years in the port of Rotterdam. So it's protected area, but salt, it's a sea. They tested with a wind force at 12 and wave height at 1.5 meters. So it's very small wave, but for this near shore place and estuary could be nice. We have also some people, some specialists in oil and gas, try to test some system or close to the water, and with here application for wind force 12 and wave height to 3 and 4 meters, so it's a little bit higher. Here it's the first megawatt scale plant installed offshore, but near the coast in Singapore, and with different tests carried out here. So we are not in full sea, so quite protected, but it's a very huge system. 1 megawatt is quite important, and they try to address all the topics, included how to install it, transport, install. Here it's Solar Duck, also a Dutch startup. It's always startup at this stage. So here we are a little bit higher from the sea, 3 meters, and they say they will stay in the offshore site, but in estuaries and protected area. But they will test underway for bigger waves. Higher and higher. Here it's like oil platform. I mean, so there were the principle of the platform. We are very high above the water. First demonstrator has been installed. It seems to be suitable for big waves, but we have to wait the result of this. But it could be a little bit expensive, but let's see. And another system under study to address big waves. He said that 20-meter waves, so it's the high waves we can have. I mean, so we're going to see how it works. Demonstrator is very important. We understand in this type of project. At the opposite, here we stick to the water and follow the movement of the waves. And the company mentioned here waves of 9 meters suffered by the demonstrator, located at 12 kilometers from the coast. So here we are in Atlantic Sea. So it could be interesting to understand how the corrosion could impact the module here. Right. In the sea. There is other demonstrator. We have things like that. It looks like a farm for fish. So this one is also it's a membrane on the water. So it follows the movement of water. So there is a lot of tests on this way, and so it depends. Sea, it's very large. You know that very well here. So open sea, high waves, statistical of big waves and big wind. So we can see how the demonstrator could give good or bad results. I would like to make a little bit of focus on Mediterranean Sea. It's not easy a place. So I found a first publication was carried by David Fernando and Andrew Blakers of School of Engineering of the Australian National University. So they try to assess wave and wind conditions at sea around the world and quantify the potential for development of floating PV at sea. So here the study studies worst conditions that floating system will statistically face at sea. And here it's I zoomed in on the Mediterranean and on Malta. So first, when I see that the conditions around Malta and in the Mediterranean in general are difficult, about 10-meter wave 8 and 20 meter per second wind speed. So you know that, but it's of course the study is macro, so you could have some local condition, local effect, etc., estuary, etc. We could find some good position in Greek island here, but Malta is middle of the sea. It's a little bit difficult, but as you said, previously, there is a lot of different technology, and maybe the oil platform design could be interesting, but we have to wait a little bit. So I'm close to finished, but last but not least, there is a point we were to discuss with Brian, and I put a slide on PV in Malta. It's just to give some picture. It's very macro, but here we have some element on PV energy in Malta, okay, and some approximate figure to give an idea of PV needed to produce the equivalent of Malta annual consumption with PV. It's important to understand that it's not our equivalent production. Okay, it's total energy at the end of the day, as a year. Okay? So to have a constant equivalent and production and consumption, you need backup, you need a management system, etc. So it's an important point, but to give an idea, we have two possibilities to understand this. It's how to we need space. Here we can see it's like 1,600,000 system of 1 kilo peak, very small one, 5 kilo, or ground mounted system. So ground mounted system needs a little bit of space because you have shade, okay? And it's look like 25 kilometers square, so it's a lot of football pitch. And square of 5 by 5, so we try to do what it represents on the map. So it's a big floating PV system, or it's a big ground mountain in Malta. So here, this simple calculation shows that it will be necessary to find space to best integrate the PV. And now it's important first to maximize the value of private, industrial and public building roof first, and to install shade structure in parking lots. It's important to this investment will reduce CO2 emission, but also reduce electricity cost and provide visibility on price. Today, all big companies in the world invest a lot in PV system because of the visibility on price. In France, SNCF, with the bigger buyer of electricity in France, is because of the train, okay? And she invests a lot on PV. Google, etc. All the biggest consumer of electricity because it gives a visibility on the price. In fact, and I will conclude maybe on this, and solar energy is free and the price is fixed. So this is a good investment for the future. And to finish, here is a site that we monitor in Malta as part of the Promise project, support for training and skills transfer. So thank you for your listening.
So thank you very much, Alexandre. I think it was very interesting. Maybe we have some time for some questions, or you just need to hold this so that we can record the question. Here you
go. I have to be careful.
No, you don't need to put it on your mouth.
No, I'm not.
Don't eat.
If I'm not mistaken, I stand to be corrected, obviously. In your earlier presentation, at the present, what I understood, on the ones already installed, the wave limitation is 1.5 meters, the wave height, for having a safe operation and all that. Is that correct? Because then you showed us that there are these platforms like oil rigs that are being experimented. But at present, today, is there still that limitation of 1.5 meter wave height? Because
it's difficult to have precise point on this, but it's close to 1-2 meters. It's very low now. Yes. But the main constraint for floating solar now it's inland. Okay, and the main point is the wind. Inland it's the wind, and it creates waves, sure, but it's the wind and the fact that we are on big reservoir. I mean, it's storage of water, and there is movement on the level and margin, and we have to organize the mooring and anchoring to adapt to this different level of water, link it to the wind, and the wind could create waves, but it's mainly the wind, the problem. And when we go at sea, arrives wave as well, etc. So that I said that first demonstrator and bigger, it's 1 megawatt, so it became bigger. It's on an estuary and protected phase. So I don't know exactly the level of swell, but you can today all biggest project far at at sea, it's are in near wind turbine. They want to go there because there are all infrastructure already there. So Dutch company and German company study a lot on this.
Thanks.
Any questions?
You know, everyone had to compare costs because finally, I think that's what makes the floating PV system viable or not. Definitely, it's much more costly to install PVs on the water rather than on a roof of a house.
Okay, when you are in the water, you have large scale solar, so you have the scale effect. But so you cannot compare exactly. So you can compare ground mounted system, large scale ground mounted system, with floating system on fresh water. This we can compare, and we know that there is I don't know 10-20% more in capex. Operation maintenance is also 20-30% more.
It's just because prima facie it looks like it will be much more expensive, especially from the maintenance point of view. To
Also
30% seem to me a little bit low as compared to maintenance on land.
On land, it's first. Today we speak about 20 or 30% more operation maintenance, but sometimes it could be very difficult because we have also birds. We have some technology. Sometimes it's not very well designed. Have cable near water, so there is also a lot of discussion between the owner to buy such technology or such technology because some was very near the water, and now they try to go a little bit higher, and they try to organize the electricity cable because of movement. We see a lot of problem with electricity fire on some of them. But now there is a good feedback, but it's not like ground-mounted system. There is optimization on performance and operation maintenance to do. I show you an example of company we work with, and the point is for us for laboratory it's interesting because we have a lot of action on diagnostic of default, aging module, etc. And when you are on the floating system, on ground you also have this, but you need drone, to have a thermographic picture, and with data mining and stuff like that, you can understand which problem linked which picture. But it's need to be very quick automation because there is a lot of modules you cannot go there. And in floating, it's more important to do this. So in floating and at sea, we have some European project, but it's research now. The problem is you have to invest a little bit because to monitor, to have sensor, to put the first thing, it's expensive. So different projects arrive, and maintenance is very important. So with the electrical data, drone data, and we can have possibility to understand where is the default and how to go to repair. For us, it's important, and also we have a lot of work on module aging because moduling is close to humidity, and some module is well manufactured for this. Some other it's not very good.
Thank
You mentioned the Mediterranean Sea. We're in the Mediterranean Sea. You know of no commercial developments of floating PV as yet, correct? From what they're still at research stage. Still at research and still small scale.
Small scale. We had a project in
Canary Islands, yes.
And we tried to go there, but the project was not accepted. But there is some, because Mediterranean condition is it's very different from north of sea.
Correct.
So today, a lot of projects north of sea because of wind turbines opportunities.
Can you explain why the difference?
Oh, different. It's maybe it's wind and a gust and swell. It's not. It's higher. I mean here, and also in there is they can go slowly because there is a lot of estuary in the north, and also they already have infrastructure. There is a lot of wind turbines, so they have data. They know very well. But the study here it's quite new. It's 2023. You have reference here. So here it's only Mediterranean, but they make a study all worldwide. And the good part is the main is Asia. Asia is very interesting, but there is hurricane. So we don't have hurricane here. So maybe in the future, but right now there is not. So, but we have no. We have some. It's like offshore wind turbine. Here we have some test near Marseille. We have 3. It's not a lot. So I maybe it's experience of Dutch.
Final question: Is there a comparison? Because now there's a lot of talk of floating, both solar and floating wind. Yes, a comparison in relation to the cost of both, because both of them have similar challenges, and capex for they're both very expensive to do. Everything that comes with it.
So what the wind is better at sea because there is no rugosity. I mean, the wind stays low and it's very laminar. So and in Mediterranean sometimes it's difficult, but the wind comes from the earth. Marseille, the wind is very turbulent. There is a lot of gusts everywhere. But in all the west part of Europe, the wind comes from ocean. It's very laminar, etc. So you can, and in wind turbine, there is scale effect. The larger the wind turbine is, the more efficient. So it's difficult to put wind turbine like, I don't know, it's 10, maybe 15 megawatts. They speak about larger. At Earth, you have 2 or 3 megawatts, and the power linked to the size. So you have huge things. It's impossible. So they try to make huge power, huge wind turbine to have a scale effect. So it's difficult to compare. I mean, now it's the opportunity to go near this. I mean, so I cannot compare very easily at sea. On inland, you can discuss because floating have feedback now. The price to be certain.
unfortunately, Malta is a small island. We don't have estuaries where we can put them and shelter it
Yes,
because we enjoy too much the sea in summer. So
because of the waves. Yes, I understand. Yes, that's why I said you have to be focused on the ground first. Wait for opportunity. It could have some opportunity in estuary, etc., near farm, etc., but it's more linked to farm maybe, algae production or. But to have a large production, it's roof, roof and parking. But we have to manage with other use of the land. And on parking, if you want to build something, you have to remove photovoltaic. And but on industries, it's the same. Today, industry said, "Oh, the price is very high, so I want to buy a PV module, so I can have visibility in part of my electricity, and I will put this near the building. But maybe in 5-10 years, I will need this space to store, to I don't know." So today, some producer who develop project propose very short contracts on 10 years maybe, and said, "Okay, I put system like concrete, very easy to install and to remove, and I propose you a contract on 10 years." So 10 years, it's easier because ground mountain contract is 20-30 years. So 30 years, it's difficult also for parking sometimes at airport. Airport in Marseille said to me, "Okay, it's nice, but if I need space, maybe I need to put the parking like that. So if there is shade, I have to remove." So I know that, but there you can some contract now it's possible. So to find solution, and you also have to manage the shadow. If you have system and tomorrow you can build it's 4 floor and urbanistic things permits to have 7 floor in front of you in the south or east, it's not.
We have those issues.
No, but all okay, but there is not a one solution, but
It was a reason for land reclamation.
and agrivoltaics also is very it's a trend in France now. Everybody wants to understand this, and we are very the government don't. We have a bad experience with sugar. Sure. You make sugar, you have big betterave. It's red. Beetroot. Yes. And we can use it to make oil. So you replace ground for agriculture to make oil. It's not possible. You have to maintain it. So they study how much PV you can put and link it to the production below of agriculture. And to be sure also that the owner of the ground, agriculture, will not say, "Okay, I stop to produce, I don't know, and I go only with PV." So there is discussion between research, agricultural research, government, etc. But we will find solution. Maybe 30% of the ground could be covered by PV. And it's interesting to avoid evaporation. We have more and more evaporation. Near Marseille, in my place, we have water for oaks, for mushrooms, and we also have water for grapes. It's new tree. We don't need this before. So sometimes it's interesting to cover a little bit the trees. Not in spring, because spring need to have a lot of sun, but in summer it's interesting. So we have some solution to develop on this, but it's specific.
my question, sorry. My question is this: in the you're talking about the Mediterranean, I see that you're taking the wave height and the wind speed. You don't take into consideration the period of the wave.
Yes, there is the length of the wave.
Mediterranean is much
Frequency.
short.
Yes, sure. There is this type of study in the different technology. They take it into account. So here it's global things. I think that they took all just key parameter, but after we have to understand the length and the frequency of the waves. Sure, it's that's why sometimes maybe system like that follow the movement would be interesting, but it's not very good for PV modules maybe.
Just one last one, maybe really hasn't really got much to do with your lectures. So, out of curiosity, in France, what is the prime source of power generation? Is it still nuclear?
Sorry?
In France, the primary source of power generation, is it still nuclear?
Yes.
And what percentage of the total? Would you know?
68%.
68.
78.
And solar, how much solar at present?
Solar, 2-3%. It's nothing.
So,
but we have big objectives to develop it. But
so you have no more coal-fired or oil-fired power stations?
There is still some coal, but it's just for backup, for peak.
No, okay, all right, yeah, all right.
We have hydropower, but hydropower there is a lot of problem of water since 2 years.
Mm-hmm.
So it's also difficult. Nuclear power have problem of availability and because maintenance, etc.
Yeah.
And we are in transition and to put a longer the time of exploitation. At the beginning, nuclear power point was made in 80s, 90s, France, all, I mean, and that was made for 40 years. Okay? 40 years is now, so we have to decide. So we have a lot of study of security to prolong it, to go to 50%, 50 years, and 60 years, because other technology are not ready. The problem is today it's nuclear technology is the research was stopped very early. So now we are on the old technology. I mean, it's a submarine of 1957, 68 American submarine.
Yeah.
So we need water all the time. So when water stops, when you are submarine, it's okay. But when you are on ground, you need to security.
Yeah.
So we need research, and our researchers said if we want to find another technology, I mean not SMR. SMR is small reactor, but the technology is the same. We need 20 years maybe something, and it could be interesting, but the problem of security is very important for EPR now.
Yeah.
We have a project in France with a lot of exceeding time and price. We have a project in Finland with always tests, not in exploitation.
Mm-hmm.
And in China, I think the third in China is stopped. I don't know exactly what. So there is a lot possible of demonstrator, but from demonstrator to exploitation in time, and we lost our time now. I don't know exactly why. It's a politic between Germany, France. It's complex. But now we have. That's why International Energy Agency said we only PV now can be deployed quickly.
Yeah.
With a levelized cost of energy low, etc. But it's quite different from a centralized system.
Yeah.
We need to find place,
Mhm.
etc. It's another way to understand energy.
Yeah. Thank you.
Thank you.
Thank you for the presentation, first of all. Do you recommend any particular PV type of PV system for panels at sea? Earlier in the slide, you referred to perovskite.
Ah, yes.
So, I mean,
Okay. So there is research on PV. So right now, when you build a big farm, a big combined big manufacturer of PV module, it's a lot of investment, and you have to understand which technology is deployed right now and in 5 years, etc. So there is a lot of new technology possible to increase the yield of the solar panel. We always need to increase the yield, and we also need to increase we need to use less materials like copper, because AG also. AG, we need if we silver. Sorry, silver. It means if we use if you produce all the module we need, we will use all the silver of the world, maybe. So we have a lot of challenge in the performance of the material and all the integration, electric integration also. So we work on different technology, but also we work on how to transfer it in manufacturing. It's a very huge company. Your first question was,
what do you see perovskite as an emerging technology?
Yes, we combine technology now with other silicium and perovskite. We call it tandem. So it could be the next technology. Not so far. Well, I don't know. Maybe I'm not an expert on material, but maybe 5, 10 years. I'm not sure. It's very interesting. Everybody work on this. And you ask for C. We test different modules, but the point is the encapsulation, and how the water can go inside or not. And we have in laboratory a chamber, climatic chamber to test this. And we can double glass module. It's very nice for that, but it's quite heavy also. But there is it's good technology for that. But we have to test. We test some module.
So very well. It looks like we had an interesting conversation, questions, yeah, debate. So thank you very much, Alexandre, for your presentation. I think energized us. And thank you once again for coming. Next week there is another public lecture, actually through Promise Project as well. It's more on reliability of photovoltaics, so what we have in place, how we can really ensure that they are producing well, more with pictures and images that they can see. We had a school last week actually on this as well. So it is very interesting images that you cannot see with your naked eye easily, with cameras, yes. So I invite you all that you join us next week as well. Thank you very much and good night.
Well done.
If there is someone put it in